goes for your chapter 2. Okay, so the first thing that is I want to introduce you in your chapter 2 is what we call the angle between two vectors. Okay, so last chapter 1 I told you vector can be going in this direction, vector can be going in another direction, etc. etc. So the thing that I want to ask you now is, if I ask you to find the angle between two vectors, okay, so that means like that, vector A is going up, vector B is going to the right. Where is the angle between the two vectors? It could be this. Can it be something else? You see, it's because of the way I draw. But if I were to extend everything out, it could be any of this item, right? Okay, so the convention that you die must remember, if they ever ask you for angle between your two vectors, you must stick to this condition. Either your vectors converge from a point or diverge from a point. Then you can pinpoint for me the correct vector. Okay, so just now I told you, no, there's so many possibilities. Which is the one that we are interested in? So by convention, I take it that, if A is here, B is here, they must come up from the same point, and then this angle theta will be your vector. So this is when they diverge from the same point. If they converge from the same point, this is the angle. So what if I draw like that? One in, one out. Where is the vector? Cannot, you must redraw into both out. So this one, B, I extend out. So it becomes A here, B here. This is the angle that I'm asking for. Okay? So the fundamental and most important rule when it comes to angle between vectors, make sure coming out from a point, both your vectors are coming out from a point, or both your vectors are pointing towards the same point. That will be the angle that they are looking for. Clear? Okay, so important thing, angle in vectors in degree. Okay, angle is always in degree and is between 0 and 180 only. In your complex number, your argument is in radians. Don't mix up, Okay, vectors in degree. If nothing mentioned, 1 dp. Follow instructions in your question paper itself. Question paper will tell you 1 dp for angles, unless otherwise stated. Okay? So, I settled the first part. Here comes the first magic formula. We are introducing to you the scalar or the dot product. Okay, the name of this mechanism is what we call scalar or dot product. This is something like an operation. How you do is like addition, multiplication. So this is something special. When I say a vector dot to a vector, vector A dot to vector B, the formula is magnitude A multiplied by magnitude B multiplied by cosine theta. Okay, remember, A dot B is equals to magnitude A, not modulus. Magnitude A, magnitude B multiplied by cosine theta. And what the hell is theta? Theta is the angle between the two vectors that we're talking about. Okay, so this is the formula. This formula is something that you must accept. It cannot be proven. This formula cannot be proven at all. If you can prove it, you can get the Nobel Prize already. Can? Okay, so congratulations, we have come to the second set of properties. Remember in your first topic, chapter 1, I told you you have 3 sets of properties. This is your second set of properties. Many items here, and you look at all the properties, look like shit like that. Okay? So this is why it's so difficult to memorize. Okay? So, important thing. This one, super important. A dot B is equals to B dot A. You can change the position. Okay? Asterisk, asterisk for you means the one that students often cock up on. Okay, number 3, is distributive law, so nothing really fantastic. Number 4 also distributive law. Number 5 also quite straightforward, nothing fantastic. Okay, so the other one that I have not talked about is part 1. Number 1, A dot B. A is a vector. If I vector go and dot with a vector, I actually get a scalar, a number. Okay, that's why it's called dot product or called scalar product. Chapter 3, you have another product, it's called the vector product or cross product. So that's when things start to go a little bit blur. Okay, so A dot B, vector dot vector produce a number, a scalar. Okay, and then this one important. Okay, again take note, non-zero. Okay, I asked you to highlight non-zero previously in your chapter 1. I also asked you to highlight non-zero here. If vector A is perpendicular to vector B, the dot product is 0. Do you know why? It's actually common sense. I don't need you to memorize this. If vector A is perpendicular to vector B, A dot B must be 0 because of this stupid formula. What is cosine 90? 0. So if they are perpendicular, A dot B must be 0. Can? Okay, can? So these, the 2 and 7 are the more important properties that should be driven into your brain. The rest of the formulas are rather intuitive, but sometimes you can still screw up. So take note of the rest. Can? Okay, so in particular, what is A dot A? Or what is U dot U? Okay, so this one another important thing. If I have two same vector dot together, what is the angle between the two vectors? That means if this is A, I ask you to A go and dot with A, or U go and dot with U. What do I get? What's the angle between the two vectors? 0. So you usually see a 0 down here, right? What is cosine 0? 1. So U dot U is magnitude U squared, not modulus. It's magnitude U squared. So this is another key property that you must remember. U dot U or A dot A or J dot J or X dot X or whatever shit you can think of, if they are the same, dot together, you get the magnitude square. Can? Not U square, is magnitude U square, not modulus U square, magnitude. Can? So I tell you all the theory already, how to do things numerically. Okay, so same thing, got some stupid formula down here for you. Difficult, Let's look at a numerical example. Okay, so look at example 1 straight away. In part A, I ask you to do A dot B. Remember, vector dot vector. So don't copy first. Let me explain to you how it's happening. Okay, A dot B, I write down the column vector. So what you need to do is follow 2 times 1 plus minus 1 times 1 plus 1 times 2. This is your dot product numerically. How you do things numerically. If you don't know what the hell I'm talking about, look at the formula up here. It's given in AB, A1, A2, all these things. Okay. So if you again follow me, it's just 2 times 1, the first row, multiply together, plus second row, multiply together, plus third row, multiply together. This is your process for your dot product numerically. Okay? Okay, if you can do the first one, try part 2. A dot with B minus C. You do B minus C first. Okay, just follow your standard rules of operation. Settle the bracket, then you do your dots. Vector B minus vector C. Thereafter, then you try to dot them together. Try on your own. Okay, so if you master this skill, means you have the skill really. So don't need to memorize formula. That's why I'm asking you to try on the spot. Okay, remember first row multiply together, add to, second row multiply together, add to, third row multiply together. Take note of the positive or negative. Confident? Confident of doing your dot product numerically? Okay, so again, take note dot product, vector dot vector produce a number. So you actually get a scalar, a number. Can? Okay, so the other items you go and do yourself like you want practice. So I have taught you how to do dot product. I taught you the properties already. So let me give you the first application of your dot product. Okay, this one die important. Can you go and highlight this header? Okay, this 2.6. Can you go and highlight? Okay, why I ask you to highlight? Because this is the way by which I hope you can master your vectors. You need to learn by skills. The moment you see an angle question, okay, if I ask you to find an angle between any vector, you must always remember dot product. Dot product produces angle between two vectors. So how does it come about? Actually, it's quite easy. This is the formula, right? This is dot product formula. I told you you cannot prove. You must remember. So how to find theta? Switch it around. Is A dot B divided by magnitude A, magnitude B. Agreed? It's actually A hat dot with B hat. You inverse cos, that will be your angle. Can? Take note So when you're writing this, because everything print for you already. When you're writing in your answer script, can you please pay particular attention to how you write? When it's a dot, you go and really go and dot. Okay? This is not the same as like that. Some people tell me same lah like that. This is multiply. Different. They are not the same. Then some people will say dot multiply ma, I can write like that. Cannot. They mean totally different thing. This is cross. This is A cross B. You learn in chapter 3. So dot is dot, cross is cross, multiply is multiply. Don't mix up. Don't be sloppy in your presentation. Okay? So dot, make sure you go and dot it clearly in your answer script. Okay? And then remember, when we talk about this theta, is the angle between your two vectors, and the condition must be met. Angle diverging from the point or converging towards the point. Okay, so remember all these little rules. So with all these little rules in place, let's handle example 2 now. Same thing, the setting of the question is always like that. No? I'll give you a position vector of A, position vector of B. Then I ask you to find the angle AOB. Okay, and then determine the area of triangle AOB. Okay, so a new skill that I wish that you will pick up for vectors is sketch. I know some of you all, the power of imagination is very strong, but by all means, please sketch. It will help you visualize. I got A, I got B. I just anyhow sketch. Okay, let's say this A, this B, this O. What angle am I interested in? AOB. So, and then roughly you know. Okay, then remember, I'm interested in the angle AOB. To find angle, the rule must be there. The rule is both your vectors must be out from the same point or into the same point. So it must be OA dot OB. I cannot OA dot BO. Cannot. Okay, either I use OA dot OB or I use AO dot BO. Either both in or both out. Can. So draw, identify your angle, write down in column vector. So same thing, the right column gives you your so-called thought process. The left-hand column gives you your actual working. Okay, so always good practice to write down in column vector. Then you see a angle question. Angle question confirm point to dot product. So cos theta, cos AOB is vector OA dot vector OB divided by magnitude OA, magnitude OB. So upstairs, go and do your numerical dot product. Downstairs, you learn in chapter 1 how to find the magnitude of your various angles. And thereafter, take your inverse cosine, Remember, angle always in degree. So this angle happens to be 150, obtuse angle. So far so good? Anyone lost? Anyone confused? Okay, after you settle finding the angle AOB, you are supposed to determine the area of triangle AOB. Okay, as of now, I've not given you a vectors formula for finding angle yet. So you need to activate your secondary school skill. How to find angle of triangle? What are the formulas that we give right now? Half base times height. What else? Half AB sine theta. Okay, so this question I already found angle, right? So obviously I can make use of half AB sine theta. I have theta. I just need to activate half magnitude OA, magnitude OB, multiply by sine 150. That is your area of triangle AOB. Okay, there is actually an alternative, but you will learn it in your chapter 3. So don't stress over it yet. Okay, right now, secondary school method more than sufficient, then use it. Don't need any additional skills yet. So far so good? Okay, let's move on to this bit. Okay, last bit for today. This bit can be a little bit more abstract. Okay, so this one, I need you to follow me. Can you all please look down? I need to demo using the table. Okay, imagine this is my origin. The edge of the table is the origin. I have a vector here. Okay, imagine this is the x-axis. Okay, where is the angle that my point, my finger here, makes with the x-axis? I want you to give me the angle that this point. Yeah, let's use this one. Okay, the head. Okay, the head down here. What is the angle that this point makes with the x-axis? If this is the x-axis, what will you do? Like that, right? You draw a line from the origin, hit up to this point. Okay. Then where is the angle? This one. Make sense? Okay. Where is the angle that this point makes with the y-axis? This angle. Follow? Where's the angle that this point makes with the z-axis? This angle. Can follow? Okay. So this is what we call the angle that your vector makes with the x, y, and z axis. And then this actually makes up the theory on directional cosine. Okay, so what I just demoed to you are these two diagrams. I don't know what the sheet. Who can understand this diagram? I don't know what I'm drawing down there. Okay, you can understand, good. You cannot understand, just remember what I just demoed to you. X-axis, y-axis, z-axis. The angle that it makes with the three axes are your directional cosine. Okay? Okay? So there are certain properties pertaining to your directional cosine. How to get cosine alpha is given in this formula. ABC divided by square root of a squared plus b squared plus c squared. Okay, so just take it down first. Okay, and by convention, we use alpha, beta, and gamma to represent the angle with the x-axis, y-axis, and z-axis. Okay, right now I'm just forcing you to accept. But actually what is happening here, okay, is actually A dot B over magnitude A magnitude B. Okay, so let me explain what the hell is actually happening here. Okay, so imagine this point is what we call your ABC. Okay, this point is ABC. Your x-axis is here. What is your equation of the x-axis? 1, 0, 0. Can accept. Can accept. 1, 0, 0. Can it be 2, 0, 0? Can it be 3, 0, 0? X-axis. How come I call x-axis 1, 0, 0? Where does this come from? Can it be 2, 0, 0? Can it be 3, 0, 0? Can it be 10, 0, 0? They're all parallel, right? So remember, they're actually the same. 10, 0, 0 is actually 10 times of 1, 0, 0, right? They're parallel, right? So if I'm asking for the angle between two vectors, does it matter whether it's 1, 0, 0 or 2, 0, 0? They are still the same direction. Okay? So this ABC is this one. 1, 0, 0 is this. Then that's your A dot B. Divided by magnitude of A, which is square root of A squared plus B squared plus C squared. Divided by magnitude of 1, 0, 0, which is 1. So this is how this so-called cosine alpha comes about. So it's actually nothing fantastic, it's actually from your dot product. You do that for beta, you do that for gamma. Can? Okay, so this actually makes up your directional cosine. Can? Not to stress too much over directional cosine, because so far, this is a new addition to your syllabus, but so far we do not have any questions coming out yet. Can you please highlight this? Cosine alpha square plus cosine square alpha plus cosine square beta plus cosine square gamma is equals to 1. This is one of the key important results that you need to be aware of. Can? Yeah, let's try a little bit. Enough really. Find the direction cosine of OP if P has coordinate 3, minus 6, 2. So take down this section.